Ontario's Ministry of Natural Resources is looking into the usefulness of water bombers when battling forest fires. It's part of a research project that officials are calling the most challenging in fire science history. Jaden Billick has the story.
The effectiveness of water bombers in fighting forest fires has been the focus of an experiment beginning in 2017 when over 100 water drop tests were conducted with 6 of the most commonly used planes in the region from lightest to heaviest. The goal of these experiments was to find out each individual plane's drop footprint coverage in a field as well as a forest. Here's wildlife research scientist with the MNR, Melanie Wheatley, with more.
And so when we talk about drop footprints, essentially what I mean is how much water is hitting the ground, where is that water hitting the ground, and where it is dispersed within the drop footprint and how much it is dispersed within the drop footprint. Every different type of air tanker has distinct different drop footprints. And so what we did is out of the air tankers that we have in Ontario and the ones that we commonly import, we tested the drop footprints to start our basic understanding of effectiveness.
After gathering physical data from real world experimentation, the next step for the team was to use theoretical energy based models of air tanker suppression, which are essentially ways to determine fire level intensity and how much water needs to be used in order to combat these fires into a smolder. However, Wheatley says this is not based off of real world applications.
We know fire intensity is exhibiting energy. And so we can guess for different levels of fire intensity how much energy is coming off of that fire. When we add water from an air tanker to a fire, what you're doing is essentially you're adding negative energy. And so we create these models that essentially say, if we know how much energy is coming out of the fire, and we know how much negative energy is going into the fire, at some point, that balance is going to be zero.
The third step was to put the information into real world studies, in collaboration with the National Research Council of Canada and the Canadian Forest Service.
And so we knew that we had to do this experiment August 1st to August 10th. And we were banking on the environment and a lightning strike to give us an ideal candidate fire that was an ideal location, that was an ideal fuel type, that had a uniform active fire line, so that we can conduct this experiment within that 10-day window.
The information is being processed, but the outstanding finding as of now is there is not one singular plane best fit for every job. And fires are needed to be assessed in order to deploy the right plane for the right job. Jaden Billick, TBT News.